In this video, we will learn how to create the accessory objects with your deformer node and how to drive your deformation with those accessory objects. First, we will understand what are accessory objects and accessory nodes. So, accessory objects or nodes are additional geometry nodes that get created with your deformer node and are required by the deformer node to derive the deformation. These are completely optional objects or nodes. It is not required or it is not necessary to have those objects, but they are created to give the convenience to the user to derive the deformation using those objects. So there are some properties which your accessory object should carry. First, it should help the deformer to derive the deformation. Second is when you delete the accessory objects or node, your deformer node should get deleted as well. So how we will implement these two properties of accessory node in our deformer? Help deriving the deformation. So if for implementing this property, we will use the translation of the accessory object and use that in our deformation algorithm. And to implement the second property, which is deletion of the object should delete deformer node. So we will connect the world matrix attribute of the accessory object with the matrix attribute of a deformer node. And by doing that, whenever we will delete the accessory object, it would delete the deformer node with it. So we saw deformer node, we saw what properties it should exhibit and how we will implement those two properties. Now let's get back to Maya and start using some code. So I'm in new session of Maya here and I will open the code which we wrote in previous chapter where we added the paint weight capability. So I'm using the same code which we used in the previous chapter to extend the capability of this deformer node to use the accessory object and derive the deformation algorithm based on that object. So we just saw that accessory node exhibits, or it should exhibit, these two properties. And the second property is deletion of accessory object should delete deformer node. And for implementing that, we will have to connect the world matrix attribute of accessory object with a matrix attribute of a deformer node. So the first thing, we will have to create this additional matrix attribute to which we will connect the world matrix attribute of accessory object. So now let's get back to Maya and start adding that matrix attribute which we will need. And we know that we are going to add that attribute inside node initializer function. And for that, for creating a matrix attribute, I will use OpenMaya mfn matrix attribute function set. So using matrix attribute function set, I will create mfn matattr or matrix attr, and using this mfn matrix attr, I will create the attribute and I will give it a long name, matrix attribute. You can just give it a name matrix. There is no need to give matrix attribute because it's already attribute, but just for the demonstration I'm using mat matrix attribute and mat attr. Okay, and this would return us a m object handle, which we will take inside mobj underscore matrix, which is open Maya dot m object type. Copy that and I will paste it here, but I will also have to add ripple dot mobj matrix. Okay, so we have created the attribute, the matrix attribute, and I will just rename that uppercase A. Okay, so now we would set the properties of that matrix attribute, and we will set it matrix attribute dot set storable to false or 0, and mfn matrix dot set connectable to 1, because we know that in future we are going to connect this attribute with the world matrix attribute of the accessory object. So after setting those two properties, here we created matrix attribute, and then we will add this attribute to our deformer node. Connect with deformer node. Okay, and so for connecting it, we will use ripple dot add attribute. Which attribute? Ripple dot mobj underscore matrix. Okay, so we have added the deformer or the matrix attribute to the deformer node, and the third step is we will design the circuitry. Okay, or I would just copy it, paste it here, and replace it with mobj matrix. So we have designed our circuitry of the node and connect with the deformer node and create matrix attribute. So that's done. And later on, as we have read all the attributes in here using the data block, we will read this matrix attribute as well. And we will read it using our data block dot input value ripple dot mobj underscore matrix, and we will store that in a data handle matrix. And using this data handle matrix, we will read the value as matrix, and we will store that value inside matrix value. Okay, so we have read the matrix attribute using data block, and we have stored the read value inside a matrix value attribute or matrix value variable. So our reading part is done. Now we will go back to Blackboard and understand two more functions which come with the deformer node. So this is the deformer node which we have studied so far, and we will see two more functions that are available with the deformer node, and they are accessory node setup and accessory attribute. So why do we use these two functions? Let's see. So accessory node setup function creates that additional geometry object which is called as accessory object in the scene, and to create this accessory object or geometry, a mdag modifier is passed to this function. Mdag modifier is a class that is used to change the structure of directed acyclic graph, or change the structure of the DAG, and it is usually used to create nodes, making new connections and remove connections of DAG. So in this example, we will have to create this new node of this geometry, and that's why a mdag modifier is passed to this function, and using that we will create a geometry object which is needed as an accessory object in the scene. So first thing, we will create object, and then as we discussed that we will have to connect the world matrix attribute of this object to a matrix attribute of a deformer node. So second thing we will do in this function is connect attributes. The second function is accessory attribute, and this function is used to return the handle or the handle of the attribute to which the world matrix attribute of accessory object is connected. So this function will return this handle, which in our case would be ripple.mobj_matrix. Okay, so now we understand what these two functions do, which we get with the deformer node. Now we will start writing the code for those two functions. So these two functions will be the part of the class. So we will define accessory node setup, and we will first pass self, and then we will pass DAG modifier, which will help us to create the accessory object or accessory node. Okay, so we have passed a DAG modifier, and then we are going to create the object we need. Create and we will, in this example, we will create a locator using mdag modifier dot create node. So using this function, we will create a locator, and we will name it locator, and we will return it in a variable, and it would return us the M object of the locator. Okay, so we have created locator. Now we want to connect the world matrix attribute of this locator with the matrix attribute of our deformation. Second is establish connection. And to do that, I'm going to use a dependency node function set, and I will call it mfn depend node or depend locator in this case. Open maya.mfn dependency node, and I will provide mobj of this locator, and I will take it in mfn depend locator. Okay, so we have created the function set for the dependency node, and we will find the attribute, which is the world matrix attribute, and we will find the attribute using function of dependency node function set dot find plug. And which plug do we want to find? World matrix. Okay, which will return us a mplug type object, and I will call it as mplug matrix. After taking that mplug matrix, or instead I will call it as mplug world. So after getting that mplug world, we will have to find out the attribute. So this is the handle for accessing the attribute, and then we will have to find out the attribute, and we will understand why we are not using mplug directly, why we are grabbing the attribute, because mplug is the way of accessing the attribute. So why can't we use mplug directly? Okay, so we will understand that soon, but before that I would take, or I will grab the attribute from this mplug. So mplug world dot give me the attribute, and I will store that attribute inside obj underscore world attr, because this function right here returns us the m object to that attribute. And why we needed that is because we are going to use a function of DAG modifier for establishing a connection, which requires the m object type data for the attribute. And that's why for this particular function we are not able to use mplug directly. So we have reached to our plug, world matrix plug, and now I will establish the connection. And we will establish the connection using mdag modifier dot connect. This connect function takes 4 arguments or 4 parameters. First, it would take the object which you want to connect, which in this case is this locator. And then the attribute of this object which you want to connect. I want to connect this attribute. Then, to which object do you want to connect this attribute? And I want to connect this attribute to the deformer node. So for that I will use a function, this mobj. So this m object gives me the m object of this ripple node. So because the DAG modifier requires m objects, so we provided m objects for the locator and m object for the deformer node. And to which attribute of the deformer node do you want to connect? I want to connect it with ripple dot mobj underscore matrix. Okay, we will take this command and take this to Blackboard to understand it more. So quickly I will show you what we have just done here is so we first provided m object of this accessory object, and then we provided the m object of this attribute. Then we provided the m object of deformer node, and then m object handle of this matrix attribute. So as soon as we provided these four arguments or these four parameters, DAG modifier knows what to connect, and after executing this, it connected these two attributes. So I will also return the status of this connection so that I would know if the connection has been established properly or not. And I would return this m status. And then I will write our next function, which is accessory attribute. And this is also the part of the class, so I would pass self to it. And the function of this is to return the m object handle of the attribute to which world matrix attribute of accessory object is connected, which in this case is ripple dot mobj underscore matrix. So that's done too. Now we want to use this value in our deformation algorithm. So whenever we will move our locator, for example, I create a locator here, and whenever I would move it to x-axis, it should deform. It should affect our deformation algorithm. So to do that, what we will do is we want to read the translation value from this matrix, because this matrix is now connected to our world matrix attribute of a locator. So whenever this locator would move, this transformation or this matrix would get affected. So if we will use or we will read the transformation from this matrix attribute, we will be able to track the transformation of this locator. So to do that, to read the translation, I would create a transformation matrix through which it is very easy to read the translation, rotation, and the scale. So to create the transformation matrix, I would use openmaya.mTransformation matrix, and I will provide this matrix value to this. Okay, and I will receive this transformation matrix in mTransformation matrix. And through this trans matrix, I will use, or I will read translation. And to read the translation, I will use a function get translation. And we want to read the translation in object space. So for that, we will use open Maya m space dot k object. Okay, and this would return us a vector value, which is translation value. Okay, so it would return us translation X, translation Y, and translation Z. But we just want to use translation X. So we would use the 0th element of this, and I will use this translation value for the X inside the math sign function. So it would act very similar to the way our displace attributes act. So I have provided the translation value X to this math sign function. This is M uppercase S space, by the way. And so we are all set with our calculation and our accessory node setup and accessory attribute functions are all set as well. And make sure you check the indentation so our functions are not indented properly. So let's save this script inside C drive plugin, and I would save it as Ripple accessory. And now I have opened a new session of Maya, and we will load that plugin. And we have saved it as plugin Ripple accessory. So copy that and paste it here. Okay, so let's try loading our plugin, which has loaded fine. And now we will create an object and create the deformer. And type is Ripple deformer. Let's execute that, and it has created our deformer and accessory object. So which in this case is transform1, and here is the locator. And you can, in the channel box of this attribute or this node, you can also see the attributes of the deformer. So I will modify the attribute of the deformer from this node and start moving it, and we can see the displace effect here. And it's not limited between any range. You can move your locator anywhere you want, and you would see the effect of your ripple wave on the mesh. So that is how we create accessory object, and we connect them with the deformer node so that we can see the effect of their transformation, rotation, or scale on those deformation algorithms. So thank you. I'll see you in the next video.